My name is Ben McConnell. I'm the Director of Federal Civilian Programs at NetImpact Strategies. I've spent my whole career building innovative solutions for the largest companies in the world, both public corporations as well as state and local and federal governments. I've worked in every technology area there is, and this really has to do with the unique opportunity I had in high school, where I was granted unrestricted access to everything at the age of 16, and I took advantage of that and learned everything I possibly could from wire to human. In my role as Director of Federal Civilian Programs and NetImpact Strategies, I really am focused on taking all that experience and knowledge I have of technology and creating fantastic outcomes for our customers. We at NetImpact like to think about software a little bit differently than a lot of our competitors. NetImpact Strategies is a digital transformation company. We're focused specifically on constructing software factories that enable the rapid manufacturing and efficient manufacturing of inherently high quality software. We've delivered over 100 programs and projects to our clients, including FPAC, the U.S. Air Force, and the Consumer Financial Protection Bureau, to name a few. I've spent the last 20 years of my career building innovative solutions for the largest organizations in the world, both publicly and privately owned companies, as well as local, state, and federal agencies. And through this experience, I've got to see a lot of different technology and a lot of different ways that technology is applied within an organization. And I've noticed kind of a couple things. I think I've noticed first that sometimes that technology is applied in a way that really lifts up the operating model and aligns it with the business model and enhances that organization's ability to realize its mission. It's an accelerant or an enabler for its mission. Or alternatively, when that technology is misapplied, where that technology misaligns the operating model from the business model and kind of creates this deadly strangulation in the organization, and it slows everything down, and the organization would be better off with pen and paper. And I'm not joking about that. I've seen a lot of technology portfolios that they would be better if they just threw it all away and use pen and paper. Achieving portfolio market fit is something that we don't often talk about within federal contracting. And a lot of this has to do with the structure of contracts and the size of the organizations, and the fact that a lot of times there are many contractors building software in partnership or kind of in isolation, actually. So portfolio market fit is this concept where you're not building any one product within your portfolio individually. You're building it really within the context of that overall organization. And what we mean by that is that each application has a set of features and a set of capabilities that it's providing, right? And if you think about your business operating model, the people that are involved in that and the process that are using that software to ultimately provide services to the public, those people and the way information flows in between them and the underlying information model that drives those processes. It's a shared information model. It's a service that a collection of people provide. If your applications aren't designed with that understanding, if you're not leveraging domain-driven design in your portfolio architecture and making the decisions of what products you should actually create, if you mistakenly build products based on a particular business function or a particular utility that you're trying to achieve, a particular set of actions, you'll often have this incredible misalignment between your tools, and you'll build a portfolio of products that is extremely redundant in terms of its features and capabilities. You'll build a portfolio that requires a lot of integrations between applications, where data is duplicated and replicated and shared between those applications. And you will have tons of teams struggling to communicate with each other. And this is kind of the first obvious symptom, is when you have communication challenges. A lot of it goes back to your technology portfolio and it's a symptom of having poor portfolio market fit. Now, product market fit is focused on ensuring that your software meets the needs of the folks that are using it, right? It's the specific users or stakeholders involved in that, and how well it meets those needs relative to the competitive offerings, the competitive products. Now, what are those competitive products in terms of product market fit? Those are the legacy applications, the legacy tools that were used prior to that product's development. How well did those meet the needs? I don't know how many times I've heard when products are developed within a portfolio, the old product was better, right? And the users of the new product that have used the old one complain constantly because new thing and it's terrible. And then all this effort spent trying to make the new thing suck less, right? To not be as bad, or be at least as good as the old thing was, and it takes years to achieve that. But you can have product market fit without having portfolio market fit. And if you don't have both, what you'll find is a misalignment between your operating and business model. So one easy example of this is within FPAC and their distributed partner network. So they have a very large network of technical service providers, universities, nonprofits, various commercial entities, and it's difficult to do business with FPAC if you go out and talk to those people. And depending on the size of that organization that you're trying to partner with, the interfaces for them to communicate information back into FPAC and to consume information from FPAC, those interfaces aren't really conducive to those organizations' operating models. And so you have these two sets of operating models that have to integrate, right? And we don't have the necessary application programming interfaces and data standards to enable that. And so it's difficult to communicate. So if you ignore the technology for a second, you focus on the basic of what we're trying to do, we all need a common language to communicate. We need common channels to do so. So that's another symptom of poor portfolio market fit. But how we can achieve portfolio market fit? NetImpact achieves portfolio market fit through a number of practices. So namely, we use domain-driven design at the portfolio level, an operating model, and the information model that enables that. Taxonomy is important. Language is incredibly important. Information is the root of the root unit of the universe, and language is what enables us as human beings to reason about that. So that information model is not an optional thing. It's for us understanding your enterprise information model, the entities and their relationships to one another, and doing that at an enterprise level, at a global level, so we fully understand your business. That's a prerequisite to really achieving a great product market fit. And if you decompose your portfolio capabilities first based on that domain-driven model, what you'll find is you actually need a whole lot less components than you think you have needed. The second major way that we do it is through our utility driven design practice. And utility driven design is not looking at the information, but looking at the actions that you're trying to take, the utility that you're trying to realize against that information. And we find this same thing where by understanding the utility, the things that you're doing, we can then leverage some architectural patterns to really bring some efficiency and alignment. Software factories are a key part of efficiently manufacturing software. A lot of times organizations, as they get into building their own software, whether it's for internal applications or applications for their customers or even their partners, they take this agile approach. And agile is definitely a very good thing, but agile is intended to deal with uncertainty. It's intended to deal with situations in where you don't quite know how to get to the end. There are known patterns, successful patterns for implementation, and the degree of uncertainty is a lot less. And so while we still want to leverage an agile iterative methodology to ensure you're achieving product market fit, the actual construction of the software, the manufacturing of the software, should be very predictable. They put out working software continuously for the business stakeholders to review, the end users to review, and then work collaboratively with the development team to refine and to better fine-tune that product market fit. So to do that, we first need an ecosystem for developers to work in, and that's really what your software factory is all about. It's about creating the infrastructure necessary for a development team to come in and stand up new application components and rapidly get those to market. So what does that look like? Well, in large enterprises, you're often manufacturing lots of different software. You're not manufacturing a single piece of software. You're manufacturing a portfolio of software, and the needs of that software is evolving. So you're having to manufacture new component types pretty regularly. And so software factories and enterprises like federal agencies, they need themselves to be agile in terms of they have to be flexible. You have to be able to stand up new component assembly lines very quickly. And when I say quickly, I mean within hours. So from the point where an idea is founded, the ability to stand up a new assembly line to manufacture that component, you need to be able to do that within hours of that idea forming. And that's really how you achieve this rapid time to market that's measured in days or weeks, which is the contemporary state of the art. Commercial entities have achieved this. They don't take months or years to get software to market. They instead look at their software development practice as a reliable practice where they can experiment with ideas, produce working software, and then if the idea was wrong, they can throw it away. And that's really the best possible way that you can test your product market fit. Let's get working software in the hands of users and testers and see if you're on the right track. So what is in a software factory specifically? Well, it's going to be your infrastructure, the process, and the tooling that enable you to rapidly and efficiently manufacture inherently higher quality software. You'll notice I keep going back to that inherently high quality software. That is at the root of what we're trying to do. We're not just trying to make software. It has to be inherently high quality, inherently secure, inherently performance fast, and inherently secure and reliable. So inherently, when I use that term, what I mean is without extra work, without us doing a bunch of stuff after the fact to get that software in that high quality state. So in a software factory, first is your network engineering practice. So you need a network that's going to meet the needs of all the communication between the machines, all your automated tools, and other automated tools, and your humans and your automated tools. Your factory workers have to have that feedback from the control feedback, your feedback loops, and your feed forward loops. And your machines need to be able to communicate with each other, and you need an underlying network infrastructure that is redundant and highly available and capable of handling that. In the cloud space, this really comes down to making sure you have your VPCs right, and you have the automation in place to rapidly provision new networks if needed, and those network address spaces are proficient for handling the demand of your organization. Next, you have identity and access control engineering. In order to efficiently stand up new assembly lines, you have to be able to give access to the right people at the right times. To do this, you have to automate access control. This is not an easy thing to do, but you also have to automate the provisioning and distribution of identities. So you can't expect manual legacy identity access control methodologies to keep up with a modern software factory. It'll end up being a bottleneck. Next up is your orchestration and your quality control engineering. So a lot of times we use the term CI/CD pipelines. Well, CI/CD pipelines in a software factory, they have to be integrated. This is no longer about a single app. It's about a broader portfolio, and it's just achieving economies of scale. And so as you engineer your orchestration and your quality control systems, you're thinking both of the shared infrastructure of your orchestration platform, making sure that's highly available and highly redundant, but also that the necessary APIs and integration points and interfaces are there so that you can quickly stand up new assembly lines using that orchestration platform. Modularization or component-based architecture is a huge component in this space of orchestration and quality controls. Like if you're not using a modular design in your CI/CD pipelines, if you're not using a library of automation components that are reusable and loosely coupled through version control mechanisms, you're missing out on a pretty huge opportunity. Finally, there's runtime environment engineering, and this is an area where there's massive opportunities for cost savings and efficiency gain. Really proficient software engineering work organizations, they can get by between 3 and 5 runtime environments for testing. Some organizations from the USDA have historically had as many as 14 runtime environments. So you look at that, and that's a factor of 4 to 5 times more cost than necessary to manufacture software. Right alongside that runtime engineering, runtime environment engineering practice is the test data management practice, and it lives within that runtime environment engineering. Understanding what data do you actually need to sufficiently test your software. Historically, a duplication and cleansing of production data sets have been used, and that's a huge waste of money. It just the work required to manage that data set and constantly move it and keep it up to date, and just to store it, it's prohibitively expensive, and frankly, it's unnecessary. It's unnecessary to validate the quality of your software and the quality of your data, to have all those duplicate copies. There's organizations within FPAC that have over 22 different copies of the same data set just for the purpose of software manufacturing. They don't need all that duplicate data, but this is where software factory engineering and design really comes in, and where we can achieve huge economies of scale. The next major part of software factory construction, or design and construction, is work center design. And one thing that we hold deep to our heart as a innovative software manufacturing company is that our employees' experience matters. And if we are able to create beautiful, fantastic daily experiences for developers, for testers, for operations teams, for product owners, for business owners, in return, we're going to create fantastic experiences for end users, for the consumers, the products that we're manufacturing. Contrary to that, if you, or on the opposite side of that, if you fail to give great experiences to the software factory staff, they will in return create poor experiences for your consumers. So this is a very important thing, work center design, making sure that the interfaces and the feedback loops and the way information is presented to each stakeholder within the software factory is really conducive to them leaving the workday with a smile on their face and having a great day and being excited to come back to work tomorrow. Portfolio transformation is the method by which you take a legacy portfolio that's riddled with tech debt and running an on-premise data center, or in a runtime environment that you're not satisfied with, and you transform that into a cloud-hosted, potentially cloud-native application that is compliant with all of your requirements and constraints. And this really gives us this huge efficiency gain. So we can accelerate cloud migrations by using automation. We have a cloud transformation engine that we've built, and that transformation engine analyzes your application source code and your existing runtime environments, and then makes future state target runtime decisions, saying this is the underlying hosting environment that we recommend as NetImpact that this application should be ported to. Then, through that analysis, it identifies any of the underlying dependencies, both database and application dependencies, and then actually branches that application source code, makes updates to it, and makes an AWS friendly or a cloud friendly version of that application. Using this branching methodology, this transformation, we're able to rapidly run through a portfolio and execute our transformation engine against every application in the portfolio, and then automate the migration of applications. As we find issues, which inevitably we'll find edge cases in which the automation doesn't work, we fix the automation to generalize its handling of that particular edge case. And from that point forward, anytime that edge case exists, it's detected and it's gracefully handled by the automation. Sometimes there's absolutely things that should not be automated. There's edge cases that, hey, this is a really odd one, we're never going to run this again. And in those cases, we'll go ahead and handle that manually. The goal is not to build automation. That's really not what we're about. The goal is to most efficiently and effectively move your applications to contemporary software patterns, so you can realize the benefits of cloud native architectures, realize the superior security, realize the improved cost, realize the improved time to market, and realize the improved reliability. We just want to make that easy. And we believe portfolio transformation, and specifically automated portfolio transformation, is the best methodology for achieving that. So in closing, NetImpact Strategies is your partner in digital transformation. We're experts in constructing software factories and transforming your portfolios. We can get you into a high-performing contemporary state and help you achieve portfolio market fit and really just accelerate your mission delivery. We're excited to partner with the USDA. We love our clients, our agency clients, and we can't wait to work with more of you to roll out this new way of manufacturing and software. Please check out our website. Our products and services are published, and we look forward to working with you more and serving the USDA. Thank you.